Jetzt wird es echt spannend, und wir bekommen Jart von Ingen. Wo ist Jart? Jart von Ingen. Und Jart von Ingen, der hat eine ganz andere Geschichte als die erste Geschichte von Marco Bergstein. Da ging es um Zentralisieren und von da aus, weißt du, mehr effektiv die Foresight machen. Und Jart von Ingen kommt mit einer ganz anderen Geschichte. Der sagt, how to stop chasing trends and start forecasting algorithm. Andere Story. Ich bin ganz gespannt.
Hello, everyone. Thank you for coming out. My name is Jart van Ingen. I'm the CEO and co-founder of a company called GetFocus. And I'm here to tell you today that the technological future is a lot more predictable than you might think. So it turns out there's patterns hidden in the citation networks that underlie global patent data that are predictive of how quickly any technology is going to get better in the real world before it has happened. And by measuring what we call improvement rates, it turns out you can predict which technologies are going to dominate long before it's obvious. So what we built are a set of AI agents that help you do all of this work, such that you can get to decision-grade intelligence, make better technology bets long before it's obvious. So here's some of the companies that we work with. Typically, we'll work with people like Matteo, so VP, SVP of R&D. Sometimes it's Chief Innovation Officers. Sometimes it's the CTO office. But essentially, whoever at your organization is responsible ultimately for the technology strategy of the business. And we do this in all sorts of fields. Basically, as long as there's patents, we can help. And luckily, there's a lot of patents in many different fields. So why should you even care? Well, all of you have an enormous problem on your hands. So most of the time when we go to conferences like this, we hear things about the accelerating pace of innovation, and it's all getting very complicated to keep track. But that's also empirically true, because if you look at the number of emerging technologies over time, what you find is that it's exponentially increasing. But what hasn't increased exponentially is the amount of time that you have to keep track of all of this. And that means that the puzzle is now growing a lot faster than you can lay down the pieces. And from here on out, it is going to get exponentially worse. Then let's look at some of the solutions that we typically find with our customers before we start working with them. So most of the time, many organizations have an enormous number of experts that work with their organization. And that's great, and that you should most definitely continue to do. But there's a few problems. Problem number one, typically you have experts in things that you are already doing, not necessarily in things that you might be doing in the future. Another problem is that you cannot exponentially scale the number of experts that you have, and even if you could, we see this quite a lot. It doesn't apply to everyone, but it does happen very frequently, which is that experts can be biased. And when they are biased, they are almost always biased in favor of their own area of expertise. So it's very difficult to find a battery guy that likes hydrogen or the other way around. And this is a problem because that leads to blind spots. Then you can monitor trends. And for trend monitoring, there's 1,000 tools out there. There's 1,000 methodologies. But typically what these will do is they'll monitor activity and they'll count it to some extent. So they'll look at investment figures, they'll look at the number of startups that are popping up in this, that, or some other area. They'll look at patent trends, they'll look at research publications, but almost always they'll count. And the problem with that is that it's a great way to figure out what is popular. But the issue is that if you look throughout history, there's lots of really popular, really stupid ideas. So just because a lot of people are doing something doesn't mean that you should, it just means that they are. So the question is, how can we actually turn all of this into a science? And turns out, you need to do 4 things. which is what we've built our AI agents to do. So first of all, for whatever domain you're in, so whether it's batteries or materials or semiconductors, you need to figure out what are all of the emerging technologies in my area without making any assumptions. So we just let our AI agents loose. They go screen global patent data and everything else that they've been trained on to figure out what is the whole long list of any single emerging technology within my business, just to remove the blind spots. Then the second step is to figure out whether these technologies are any good for the use case that you have in mind. So certain technologies just don't work for certain use cases, or they might be too immature at the moment to take seriously. So we need to figure out what are they, how do they work, and do they apply to what I do. And for that also we've built AI agents. Then the big question, so you can think of these first two steps as a funnel, right? What is everything? And then we want to narrow it down to those technologies that you can take seriously. But the big question that remains is how quickly are any of these technologies going to get better? And this is the key thing that makes us different from everyone else. Like everyone has a way of monitoring, but the issue is that this is a dynamic system and it's constantly changing. Every year technology will get better. The question is how quick. Because if you're in R&D, you have to plan way ahead, and usually you have to make bets when the technologies are still quite immature or when a lot of stuff is still uncertain. So the question is how quickly will it get better? And this turns out to be predictable, and I'll tell you exactly how that works. And then finally, when you figured out which technology is going to win, we have a suite of what we call deep dive and monitoring agents, which will help you answer whatever question you have about the technology, what the competition is up to, how exactly it works, how it's evolved over time, and to set triggers as well that will warn you when the technology has reached a certain threshold. That means either it's time to take action or to hit the panic button. So before I tell you about exactly how it works, our forecasting methods are inspired by and co-developed with MIT. The US Department of what used to be Defense was our launching customer back in 2021. We won an innovation award at the Consumer Electronics Show, first time they ever had the AI category back in 2024. And also our insights are used in the US White House to partly determine the national technology strategy of the United States. Right, so how on earth can you predict which technologies are going to win? So back in 2018, I was at the AI department of Volvo Cars in Sweden. And I went up to the head of that department and I pitched him about, hey, what if we stop guesstimating what happens in the technological future and we start to try to measure and forecast it? So they liked that idea, so we started working on it. And then I found out that there's a group of researchers at MIT that have been working for 30 years on trying to figure out what even is technological change, why do some technologies win and some lose, what is Moore's law exactly, why are some hyped and they go away and others fly below the radar and all of a sudden they dominate. And at some point, these guys figured that although there's lots of theories about this, they didn't have much data. So what they set out to do was to empirically measure how technologies have actually evolved over time, both from a performance and from a cost perspective. So they defined these 28 domains of technology, going from 3D printing to magnetic information storage, DNA sequencing, you name it, they looked at it. And for each of these domains, you determine a key performance indicator, which always reflects the trade-off between the performance of the technology and the cost. So basically, for every year in which a device is on the market that falls into one of these categories, you look at the performance, you look at the cost, and you do that for every year in which you can find devices in that category. And you track over time how quickly did how much bang for my buck I got improve over time. Now, that sounds a bit theoretical, so let me show you a practical example. in the case of hard drives. So here we're looking at HDDs, the old school magnetic spinning disks to store information. Every dot that you see on the graph is a hard drive that was on the market at a certain point in time. And so you can see on the y-axis how many dollars you would have to spend per gigabyte of storage. And you can see that it got a lot cheaper over time. But the interesting thing about this chart is that the y-axis is logarithmic. So what looks like linear progress is in fact exponential. And what is also interesting is that the rate of change over time is remarkably consistent, in this case averaging at about 32% year over year. Now, what they found, remarkably, is that this pattern of consistent exponential progress at a certain percentage year over year can be found in every single field of technology that they measured. Only difference being that from field to field, this rate or this law is very different. So, for example, at the top you can see optical telecommunication, which improves at about 62% year over year. And all the way in the bottom, you can see milling machines, which improve at about 3% year over year, and everything in between. Now, even with 3%, right, if you think of it as interest on a bank account, 3% plus 3% plus 3% eventually becomes an exponential curve. But of course, if you get a 62% interest rate, that exponential curve will be a lot more aggressive. Now, so far so good. We know that there's this law of progress in any field of technology that you look at if you measure it properly. But there's also problems. Problem number one is it took them 6 years to do this. Because you can imagine, for all of these dots, you have to go back into the history books, look at spec sheets. It's a whole mess of a job, and it takes an endless amount of time. And problem number two is that you can only do it when it has already happened. And we're in the business of R&D, so we need to figure out ahead of time what is going to win. So the question is, how can you predict it? And that's when we started thinking about patents. So why patents? Well, generally speaking, before it's on the market, you'll find it in the patent literature somewhere in some way, shape, or form. Virtually everything gets patented in one way, shape, or form somewhere around the world. The only thing, personally, that I think is funny about patents, because it can be quite dry subject matter, is that it's literally the only thing that we actually agree on globally. So in the late 1800s, all of the world economies that mattered came together in Paris for the Paris Convention, which is where we globally standardized the IP system, meaning that a patent in Germany looks virtually the same as one from China, Japan, the United States, the Netherlands. There's some tiny differences, but by and large, it's exactly the same system. And because it's so well standardized, it is perfect for AI, because AI loves well-structured information. Now, normally speaking, we think of patents as legal documents, which technically they are, but it's also kind of weird, because if you look at a patent and you zoom out a bit, in every patent you basically say the same 4 things. You say, here's what I've invented, here's what I'm improving over, and you cite back to prior inventions that solve the problem in some older way. Here's why mine's better, and then you say, here's exactly how it works, and that's when you get the long piece of text written by a lawyer that puts you to sleep. So, turns out, point 2 is critical, the citations. So with these citations, we can calculate interesting things. Imagine, in this super simplified example, that we've invented something in 2022, and we cite back to an older document from 2019. That means that apparently it took 3 years before we were able to come up with the next step for this field of technology that was worth patenting again. This we call cycle time, And the easiest way to think of it is for a field of technology, how many years does it take to come up with the next step? The next thing we measure is once this new invention has been published, how much does it get cited by subsequent steps, which tells you something about the magnitude of the step forward. This we call knowledge flow, and the easiest way to think of it is as how big are the steps. So how quick are the steps, how big are the steps? Then what we do, again with AI, so imagine now we have a whole long list of 40, 50, 60 emerging technologies in your space that you want to monitor and you want to figure out which one's gonna win. For each of them, we make a unique patent landscape because we need to find every single invention throughout all of history that has contributed to this technology. Then when you have all the patents, you divide them by year. And for each year, you calculate the cycle time and the knowledge flow. So how old are the patents that are being cited, and when they get published, how much do they themselves get cited? And that turns out to be a remarkably strong predictor of the rate of improvement of the technology, because we found out with MIT that technologies that improve fast have short cycles, and when new generations of patents get published, they tend to get cited a lot. Whereas slow improving technologies have very long cycles, and when those patents get published, they hardly ever get cited by subsequent steps. So whereas your average optical telecommunication patent, when it gets published, it'll cite back 3-4 years, and then when it gets published, it gets cited at least a handful of times on average. Whereas for milling machines, they'll cite back 40, 50, 60 years. So we're improving over really old information already. And when they get published, they hardly ever get cited by subsequent steps and everything in between. So basically, if you can just find the patents, you measure these two metrics, you can very accurately predict the rate of improvement. And then the question became, okay, cool, nice science experiment so far, but can we actually use this for anything practical? So what we did, and I'll just show you one example, but if you're interested, we have dozens of these cases, is we looked at a case from the automotive industry, the hydrogen fuel cells versus batteries. Because although now all the hype is around batteries, for a long time it was about hydrogen fuel cells. And in the late 90s and early 2000s and even later, automotive industries all around the world sank billions and billions into fuel cell development. And so the question is, could you have seen coming that that was a bad idea? So here you see two lines. So on the y-axis we have the rate of improvement. Now, whether it goes up or down doesn't really matter. Again, think of it like an interest rate. So even if it's going down from, in that case, almost 100% back to about 50, that still means that you get 50% improvement. And so here you could have seen since the early 2000s that lithium-ion batteries were improving much, much, much faster than hydrogen fuel cells. So that also means that you could have seen coming already then that we would have a lot of batteries now and not so many fuel cells. Same story for solid-state drives versus hard disk drives that we could have shown you in the 80s already, that disruption was going to happen. Same for online payment versus offline payment. Nowadays, we pay everything online. It wasn't always like that. In the mid-90s, with our metrics, you could have already seen that it was going to go in that direction. And we can do this for any technology domain. As long as there's patents, we can find out what are the emerging streams and tell you which one to bet on now to make sure that you win in the future. So long story short, if you just give us one of your biggest challenges that you're trying to figure out now, what we'll do is we'll go scout every single emerging technology in that space. We'll make all the data sets. We'll objectively and accurately measure how fast these technologies are improving. Based on our historical case studies, the fastest improving technology always wins. We have never found an exception to this in any field. That means that as soon as you can see these rates of improvement, you can already see the technological future. And that means that you can make better, smarter investment decisions and get a totally unfair competitive advantage compared to those that don't have such technology. Thank you very much.
I have one question just before the break, just one. What do you sell? Services, consultancy, tools? What is it that you sell? I didn't get that.
It's a platform, but we do all the work.
Oh.
So, or well, the AI does all the work. So basically, if you just if you come to us with a challenge, we'll go figure out what are all the technologies. The AI will map everything out. At the end of it, you get a dashboard that monitors that particular challenge.
But can these people take a subscription on your platform?
Yes.
A subscription.
Yeah.
You have a website, you can go there and
Yeah.
you know, I'm your salesman. No. Thank you very much for now. It's good to see it. Thank you.
Thanks.
We have